Hey guys, this is a motor design for a torpedo, submarine, a speedboat. Depending how many motors you have, the faster you go. Each motor, in this case I have a design for 12 engines. You got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 engines. You can go up to 40, 60, 80, doesn't matter. You could go high as you want. Just the more motors, the more speed. In this case, for example purposes, each motor has a rotation of 4,000 RPMs. So we're going to start from the back. This is the back one, number 12, is affixed to the deck of the subs, torpedo, or speedboat, or whatever craft you have. This will be attached to the bottom, the deck. Everything else is spinning on its own. So this is engine. Each engine's got its own fuel supply, separate, so it allows a separate rotation. It's not bolted down. That's optional, like I said. This is engine 12. Rotate this way. Everything rotates this way. It could be if you're gonna flip it the other way, you could do that same. But everything has to flip the same direction. All the motors have to rotate the same direction. And in this case, for example purposes, each engine spins at 4,000 RPMs. That's what got 4K, 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 and so on. So, engine number 12 is going to spin this way at 4,000. Then this engine is bolted down over here, but it's got its own separate rotation. And same deal with the number 11 and 10 over here. This one's got its own separate rotation, but it's bolted down to this. But it's got its own separate rotation. So each engine is bolted down to the other one, but it's got its own separate rotation. It's all in series. So you got 12 engines, each one producing 4,000 K rotation RPMs. But because they're all bolted down, they're all interconnected. But each one individually got its own rotation separate from the other one. So this one's rotating separately. So, and what I'm trying to say is, this is being the front one and going backwards in this direction only for example purposes. This front one is going to spin slower than the one behind it, going this direction. So 12 is going to spin 4,000, but because this one's on top of this one, but it's separate rotation, and it's spinning 4,000 too, but because it's on top of this one, it's going to spin faster because this is already spinning at 4,000. It's already spinning at 4,000, but because this one's on top of that rotation, you add 4,000 to that. That's 8,000 RPMs. And then if you got 8,000 RPMs over here, rotation, because 4,000 to 4,000 is 8,000 RPMs. So on top of this one, you got this one bolted down, but it's got separate rotation. So you got 4,000 RPMs. This one's on top of this one, so 4,000. It's already rotating 4,000, and you add 4,000 more, that's 8,000. So this one's spinning at 8,000, and then this one's bolted down, and it's got separate rotation. For this one, it's going to spin 4,000 more than this one. So this one's already 12,000. So this is going to spin 16,000 RPMs on this one. So what I'm trying to say is a cumulative speed of RPMs, because they all have their own separate rotations on top of the other one already rotating. It adds more velocity RPMs to each one. So it's 4,000. 8,000, 12,000, 16,000 RPMs, and so on. So 12 engines equals to 48,000 RPMs, which is right here. 48,000 RPMs total at the end of this rotation right here. This propeller is spinning at 48,000 RPMs. So each motor produces 4,000 RPMs. At the end result, you add all these together, or multiply 12 engines times 4,000, you get 48,000. You can add them up, or you can multiply, and you get the same number, 48,000. So 48,000 RPMs total thrust for the propellers. That equals to 383.97 knots per hour, which is 333.6 miles per hour. That is the velocity of this vehicle. You could do the math also. If you added 40 engines instead of 10 or 12. See, if this is 12 right here, it's 48,000 RPMs. But if you had 10 engines, that's 40,000 RPMs. But if you had 40 engines, that would be 160 1,000 RPMs. Now, what speed is, basically, the boat speed is one engine produces 27.8 miles per hour per each engine velocity. So if you have 40 engines, that's 1,112 miles per hour. That's right. 40 engines equals to 1,112 miles per hour if you had 40 engines. But in this case, we have 12. And 12 is 333.6 miles. If you had 10 engines, that's 278 miles per hour. So this vehicle can get faster or slower depending on how many engines you add to the system. And each engine could have a higher RPM or lower RPM, or it's just the design of the engine. Also, you could also by having higher RPMs or lower RPMs, you could also by the how fast the knot velocity of the propulsion, or the miles per hour propulsion of each engine, how much thrust can it produce for the propulsion. Point is that in this design, for a speedboat design, engine propulsion for a speedboat, this speedboat will be producing at 48,000 RPM at the end, which equals to 333.6 miles per hour, which is 383.97 knots per hour for this speedboat, torpedo, or submarine. It could go up to a higher if you wanted to make it to 1,000 miles, 1,112 miles per hour. Then you need 40 engines at that RPM velocity to equal that speed. So this is a hyperspin engine, and that's my invention. Hyperspin means that each engine's interconnected. Like in this case, this engine is bolted down, but the top one, or the one behind it, or the one that next to it, it's always going to spin separately from the one on the bottom. So in other words, this one's bolted down but spinning separate, and each one after that is bolted down to the other one but spinning separate rotation on top of the other rotation on the bottom. So basically, it's going to spin faster and faster and faster and faster and faster, even though they're all spinning at the same rotation, but because they're bolted down to the other one on the bottom, then the next one actually is going to always have more rotation because it's spinning on top of the other one, adding more speed and more speed and more speed and more speed. And the more engines you put in there, the faster it's going to spin. And that can go for speed cars, really fast speed cars, hyperspin train systems to hyperspin, you name it, speedboats, submarines, aircraft carriers, even hyper velocity aircraft. Anything that's got a motor could have this design where it makes it faster and faster and faster and faster. And that's why it needs a separate fuel system, and each engine has to have a separate engine and a separate fuel system to feed the energy. It's going to take more energy for more speed. Yes, you're going to burn a lot more fuel, but you could easily break the speed record of any previous known to man. But in this design, you can now go as high as you want with the speed velocity. It's unlimited. You could go very, very fast. Anyway, this is my invention. And my YouTube channel, you probably know, it's Megatron Inventors. And these are all my inventions. And I know this invention concept of hyperspin, which is everything's in series, and it's connected to the other one, and bolted down, but the one in front of it, it's always going to spin faster than the other one because it has its own separate rotation on top of the original rotation, making it faster and faster and faster and faster. That's a hyperspin invention of mine. It's all in series, interconnected system of motors. The one in front of it's going to spin faster than the other one, the one behind it. Anyway, you guys have a good one. This is going to make advanced technology around the world for all kinds of motors, including tools.